I'm not answering, I'm just getting ready. This is what you're trying to fill in. In blue, I'm writing what the little x approaching infinity or negative infinity means as far as what direction you're headed. You can think of it as to the left and to the right. What's the graph doing? You can think of it as to the left and to the right, but for the notation, you have to write that new notation as x approaches negative infinity. That means as you go to the left of the graph. As x approaches positive infinity, that's as you go to the right of the graph. So remember, x values left, right. What do the y values measure again? If x values are left and right, y values are lows and highs, downs and ups, etc. What's the degree, guys? Odd. Same or opposite? Same or opposite? Opposite. Uh-oh, but a negative. Flip it. Okay, so what's going on to the left? F of x's are going up, which means I'm going to answer it with, well, how do I show going up? Infinity, right? Yeah. What's going on to the other direction? Down, negative infinity. And if you need, you could actually think of something like, oh, hey, it's going to be going that way. And then think of, oh, to the left, f of x is going positive infinity. To the right, negative infinity. Let's unveil the graph and see. Oh, that's not how I unveil it. Lo siento. I'm not even asking, could you figure out all the in-between? I'm just asking, are our ends correct? Yeah. Yeah, they are, and our notation says that. What's the degree of the second one? Even. Opposite. Am I good? Yeah. So think of going up to the left and up to the right. So what are my y's doing as I go to the left to the right? Both of them are going to positive infinity. Did I get the ends correct? Yeah. On Friday, we saw that some fourth degrees are a simple parabola. He's way more complicated, but the ends are correct. How about this last one, even or odd? Odd. So same or opposite? Opposite. Am I good? Because it hasn't been reflected, right? So therefore I can think, okay. So as I go to the left, what's f of x doing? Negative infinity. As I go to the right, f of x is going to? And you might not have gotten the entire graph, but are my ends correct? Yes. So is that all I can tell about higher order polynomials is just the ends? No, we can tell more than that. So what if they start asking us about zeros? Zeros, they're intercepts. The picture has to do with if my graph has a smooth turn going from increasing to decreasing, I'm going to have a maximum. Or going from decreasing to increasing, I'm going to have a minimum. It's talking about turning points. At most. We saw some parabolas that had absolutely no zeros, although they could have had two if they had been repositioned. So when I say polynomials have at most, that means sometimes they have none, sometimes they only have one or two or three, depending on the degree. So when we have an nth degree polynomial, at most the polynomial can have n zeros, like a parabola. You guys just did this whole worksheet. Parabola, the degrees are 2, and how many zeros at most could that parabola have? 2, but we also saw ones that only had 1s, and we also saw ones that had none. So just because it's at most doesn't mean that that's exactly what's going to happen every time. But at most, that's how many they can have. So a cubic can have 3 zeros, a quartic can have 4 zeros. It just depends on the nature of the beast as to whether they'll have that many or fewer. And at most, n minus 1 turning points. A parabola, 2 minus 1, can only have 1 turning point. A cubic, 3 minus 1, can only have 2 turning points, etc., etc. Now, in homework, here's the dealio. It's supposed to be due tomorrow by 7 a.m. Is that going to work if we still have 4 pages of notes left? No, because it's chapel day. We had spent a little too much time grading our worksheet. However, should you guys be able to play with end behavior, zeros, factoring, etc., polynomials? Yes. Because some of them are going to be fairly basic where you have some GCFs that you can pull out first for factoring. And then you can factor use the quadratic formula if you're left with a quadratic. If you're not left with a quadratic, well, I think we're going to a future section which is a little bit harder with things like the rational root theorem, the factor theorem, the remainder theorem, synthetic division, long division. These ones are going to be fairly basic zeros, though, because you guys would see to factor this, what's the very first thing you would do? Yeah, you would pull out a negative 2 squared, and you would end up with an x squared minus 1, which we could then go ahead and keep factoring, right? With that, kiddos, I think we're done for today. So thanks for hanging in there. This homework will be due Wednesday at 7 a.m., but I'm not sure we're spending all of tomorrow on this section. Just a warning. Bye, guys. See you later. Sorry, Austin, wrong way. There you go. You can grab a picture of it if you want on the way out, bud.